This video will describe IMAAC support that can be provided in response to a Radiological Dispersal Device, or RDD, incident. A radiological dispersal device is a device that causes a purposeful dissemination of radioactive material without a nuclear detonation. An explosive RDD, often called a dirty bomb, uses conventional explosives to disperse radioactive material. For an RDD incident, there are two types of human health hazards that must be considered: the health impacts of the radioactive material released and the hazards from the explosive blast itself. IMAAC can provide model predictions and model products showing both the impacts of the explosive overpressure from the blast and the impacts of human exposure to airborne and ground-deposited radioactive particles. IMAAC products will show areas where radiation dose levels may warrant sheltering or evacuation of the local population, longer-term relocation of the population, or embargo of contaminated agricultural crops or water. IMAAC products can also show dose rates that workers responding to the incident may receive in different areas. In making IMAAC predictions, assumptions must be made about the characteristics of an RDD, including the sizes of the particles released into the air and the amount of explosive. Particle size will depend on the type and form of the radioactive material assumed to be in the device, and the surrounding environmental material, such as soil. The size of the particles will impact how fast the particles settle to the ground and how far they transport downwind. Some material may be released as very large fragments called ballistic particles that fall quickly in a roughly circular pattern near the device location. These ballistic particles are not significantly affected by the wind. Some larger particles are carried downwind. The smallest particles are carried farther downwind. The amount of explosive charge is typically described as the equivalent mass of TNT that would have the same explosive energy as the device. The size of the explosive charge affects how high the particles are carried in the air, which then affects how far they are transported downwind. Observations of the damage caused by the blast and the size of the crater that is left in the ground can help IMAAC modelers estimate the size of the explosive charge. IMAAC products that are unique to an RDD incident include the prompt blast overpressure effects, including maps showing the distances as circles for lethal impacts, lung damage, eardrum rupture, and shattered glass. These distances are referenced from technical manuals from the International Association of Bomb Technicians and Investigators. While the overpressure effects are shown to extend in all directions equally from the detonation point, the effects can be mitigated by buildings or terrain. In reality, the areas will not be perfect circles as shown in IMAAC product. It is important to remember that these blast impacts assume individuals are in an open area, without protection from being inside or near buildings. A unique IMAAC product for a radiation dispersal device incident is the unknown RDD product. In the immediate aftermath, it may not be known what type of radiological material was contained in the device. For this reason, a product may be needed that generally describes the impacts of typical RDDs. This unknown RDD product can be produced to aid in the response until more information is known, and a more refined product can be generated. This product will show two areas: an initial hot zone and a shelter-in-place zone. The hot zone is a safety perimeter 250 meters, or approximately 800 feet, in all directions around the explosion location. This perimeter is to protect the public and responders who are not involved in life-saving rescue operations from potential radiation exposure. The shelter-in-place zone extends from 500 to 2,000 meters, or approximately 1,600 feet to 1.2 miles, from the incident location. This zone is meant to protect the public from low-level radioactive contamination and external radiation emitted from radioactive ground contamination. These are some of the key aspects of radiological dispersal device incidents to understand when interpreting IMAAC products. For more information on IMAAC modeling, please view our other videos in this training series or visit fema.gov/IMAAC.